Hello, everybody, and welcome back to video 2 of the Introduction to the Neural Network series. This is the second and the final video. People who have not watched the first video, I'm going to leave a link of that in the comment section. In the first video, I introduced the concept of a neural network, explained the concept of a biological and the artificial neuron, and talked about convolutional neural network and recurrent neural networks. In this video, I'm going to primarily focus on how neural networks are trained and leave a commentary around the future of neural networks. With that, let me just take you to the presentation and Introduction to Neural Networks, Part 2. Again, we're going to talk about training of neural networks, leave some time for application, a few applications of neural networks, and limitations and future of the neural networks. Now, here in this video, my focus is to introduce you to the concept of backpropagation, which is a mathematical technique used to train neural networks. During the training process, the neural networks take in input data and make predictions about the output. The difference between the predicted output and the desired output is called an error. For instance, you kind of try and train a neural network on capturing or identifying images of the horse. Now you train it with a lot of data and then it predicts something which looks like a mule and not a horse. The difference between the horse and the mule, simply put, is the error function. Backpropagation is basically the technique which works by calculating what is called a gradient of the error with respect to weights and biases. In this, I've introduced three words: gradient, weights, and biases. In the first video, I did talk about weights and biases, and as a form of recap, let me just kind of reinforce a weight is a parameter that determines the strength of the connections between the neurons of the network, which is how efficiently the neurons are connected, how are signals flowing between multiple neurons in the network. And bias are the parameters that determine how easily a neuron in the neural network is activated. Now imagine a neural network as a light bulb and neuron being the switch. Depending upon a threshold signal that the neuron receives from other neurons, would that be activated? Like in a natural neuron, a particular activation of a neuron helps a signal which makes the human body think and act. Similarly, an activation of a neuron enables the neural network to process information. Now, I had introduced the concept of the gradient, and gradient is basically refers to the rate of change of a function or an input or an output with respect of its parameters. And in the case of a neural network, the gradient represents the direction of the steepest ascent of the error function, or where the error, which is the difference between the actual output and the predicted output, is the highest. Simply put, in the context of backpropagation, with the use of weights and biases, in the opposite direction of the gradient, the error will decrease, which means if we go in by adjusting the weights and biases in the direction opposite to the error function, or where the error is the steepest, the error will therefore decrease. With that, now let us kind of explain the process, which is put in these bullets A to E in the slide here. Basically, the algorithm or the backpropagation algorithm works by fast forwarding the input data through a network and calculating the output and the error. First, the error gets calculated, which is again the difference between the actual output and the predicted output. Then the network goes backwards through the neural network. It calculates it backwards through the neural network, calculating the gradient, which is the highest error function, and then adjusts the weights and the biases, which is the activation of the neurons, exactly to the opposite direction of the gradient, and over a period of time minimizes the loss or the error function. It repeats it over periods of time by adjusting the weights and the biases, which is the variables that determine the strength between the neurons, and also the factors that activate the neuron, to the extent where the error function is minimized or almost zeroized when the actual data and the predicted output remain the same. That is where the neural networks achieve its goal of predicting either an image or a video or an alphanumeric or any numeric or a set of letters to the level of perfection that it is intended to. With that, we've kind of come to a conclusion of the training process of neural networks, and now let us kind of figure out what are neural networks used for. Now we know about, we did talk about image and video recognition, where the convolutional neural network picks up an object and recognizes the object through the process of convolution. Similarly, in the recurrent neural networks, which is the natural language processing, language translation, speech recognition, which is the Google Assistant, the Siri, text classification, and so on and so forth, are NLP tasks. Then we have robotics, where object recognition, grasping, movement, and motion control, and it has multiple applications across healthcare, financial services, and in healthcare, basically through the convolutional neural network, medical image analysis, a disease can be analyzed, or the disease or can be analyzed from an image much more efficiently than the expert eye. Has applications in the diagnosis, in pathological setups, and so on and so forth. In gaming, neural networks are used to build intelligent agents in games that can learn and improve over time. So as the neural networks are getting scaled, right, we will see multiple applications in business and commerce. And in a following, in a subsequent video, I'm going to talk about industry specific applications of neural networks. Wait for that. And now I'm going to kind of just touch upon the limitations and the future of neural network. Obviously, as we know, that huge amount of data is required for neural networks to be trained, and it can obviously be a computational and a data intensive process. The second important thing is neural networks are like a black box. It doesn't tell us exactly how the outcome came in, which is the interpretability of the network. Now, these are the classical limitations, and in the future of the neural network, see, there are novel computing architectures, which is the graphical processor unit, the TPUs, which increase computing power and becomes easier to kind of manage huge amounts of data. And the cost of computing, as it comes down, makes it easier to massage data and make neural networks more effective. The second important thing is the hybrid models. The future of neural networks is not about any particular technique used in isolation, but convolutional, recurrent, attention-based models coming together, which is I'm kind of doing image processing and I'm doing text processing at the same time and bringing it together. Now, there are certain recommendation engine which actually do image processing and text processing, which are changing the way personalization is working. So hybrid models around neural networks is not something in the remote future. It is already in vogue. The third important thing is expendable AI, neural networks that are more and more interpretable, which means it is no longer a black box. I understand what went into it. But the big thing going forward is neural networks that process information from multiple sources, which is actually an extension of the hybrid model, video, text, and audio getting processed simultaneously, which gives a different kind of a leverage to data, and therefore business models can be built around it. Now, the series of two videos, the idea was to explain a complex topic easily. Do let me know how it landed with you. If you have any questions or clarifications, do drop in a comment, do drop in a note or a comment in the comment section, and I will respond back. Stay put for more videos around digital technologies, digital strategy, and how the world is changing. Thank you very much.